this, and then we'll go right into our review for the test, okay? So first, the reason I'm going over this again is because I know I had you guys do it on your own, but I also want to emphasize that this is really the main point of this next test. This next test is about functions, right? A lot of it is about functions, function notation. Well, this is exactly what this is. It's a function. So we've got this first problem, and I'd like for you to write out your linear equation, though, without y, using functions like f of x, such, because a lot of you struggle with this kind of concept. And that was really in the beginning. And then once you did your homework, most were good at that, and then some still had problems with evaluating functions, knowing when to plug in what values. So if we look at this first one, a phone company charges a flat rate of $25 every month. In addition, they charge 5 cents for each minute of service. Again, remember I told you I wrote this one when, phone companies used to charge for minutes? So what would you consider instead of minutes now? What would they charge you for now? Data, yeah, data and then overage of data, exactly. So think about like 5 cents for each minute of service as if it were like 5 cents per gigabyte, even though that would be absurdly low. It'd be more like 5 cents per megabyte, really. So the question first says, write a linear equation for the monthly charge based on the number of minutes and service each month. Minutes of service each month. So what would our function look like for this? How do we start this off? What's our important facts? What do we got? What is some important stuff? Good.
Well, you're going to need a variable for each minute.
Okay. So what variable are we going to use for number of minutes? M for minutes? That works. So we'll use M as minutes. Okay, what else? We definitely need to define variables, right? M starting with?
So the flat rate would be 25. So
What does that mean then, George?
sort of like a fixed rate, basically it's a y-intercept.
Yeah, how do you know that's a y-intercept?
Because it doesn't change.
It doesn't change. Even if, you know what, if you don't use your phone at all this month, how much does it cost you? $25. If you use 0 minutes, literally, right, 0 minutes, it still costs you $25. That's the y-intercept, the coordinate. Let me, before we go any further, define what our y-coordinate is. We're going to write this function as a function of c of m, the cost as a function of minutes. So c of m is our cost function. This is why I'm talking about this for a little while, because I want you guys to see function notation. So c is the cost as a function of m, the number of minutes. And as we said a moment ago, if 0 minutes are used, if 0 minutes, let's put the coordinate here. If I set m equal to 0, what's the cost still going to be? 25. There's your y-intercept. If it wasn't obvious to you that 25 was the y-intercept, think about what causes $25 as a cost. 0 minutes used would cost $25. So your coordinate tells you when x is 0, you must be looking at the y-intercept. Bridge.
So c of 0 is basically 25.
That's exactly right, Bridge. Very good. So another way of writing this, and that's how I really was going to write it, or should have written it, I guess. Bridge points out, c of 0 is simply 25. That gives us the coordinate 0, 25. Okay? Now, if that's the case, we start with our function right away. We think about, okay, we've got a linear equation here. This is a function c of m. And I know that the initial cost is going to be $25. So far I've got it all written out. What am I missing still? What am I missing? The charge per minute. Not minute per seconds. Charge per minute. Okay, what's the charge per minute, Hannah?
5 cents.
5 cents per minute. So, how do I write 5 cents? Do I write 5 times m?
No, you write 0.05.
Why 0.05?
Because you...
Just whole number 25 argument is dollars.
Yeah, 25 is in the units of dollars. So everything has to be in dollars. So it's $0.05 per minute. Even though you said 5 cents per minute, let's make sure we all see that. If I put 0.05 and then m there, it tells me that I'm paying $0.05 times every minute plus $25. So my units are dollars plus dollars. It is dimensionally true. Okay, the word would be dimensional analysis, but they're dimensionally true. They have the same units. This will give you dollars. This will give you dollars. Together give you a cost in dollars. If you decided to use 5 as your slope, what should your y-intercept have been? Let's see who can do this. 2,500. Very good. Right away. If I use 5 for my slope, it means I'm putting everything in cents, right? 5 cents times per minute. Well, this would have to be in cents also, and $25 is 2,500 cents. Meaning increase it by 2 zeros because watch, You slid this over 2 spots, you're increasing by a factor of 100. Slide this one over 2 spots, you're in 2,500. But that's depending upon which unit you chose. And that's up to you, actually. I would personally choose dollars because it was all given in dollars, but if you wanted to change it up, you can. Interpret the slope. Interpret the slope in words. What is the slope? The slope?
0.05.
But in words, I said. In words, what is it? Interpret it.
Oh, it's the cost per minute.
Cost per minute. Okay? Part B is cost per minute. I'm going to ask you questions like this in the test for sure. So when you're given a function and you know the context of the function, you need to be able to describe what it means. And you've done well with this so far. So the slope is the cost per minute. That's part B. The y-intercept we said already is what? What's the y-intercept in terms of interpretation, not numbers? What is the y-intercept interpreting-wise? George?
Monthly rate.
The
Monthly rate.
Yeah, the monthly flat rate, let's say. Let's say the flat rate per month. Because it is the thing that doesn't change as a function of minutes. It changes every month, but you only pay on a monthly basis. So even though we're going to call it a monthly rate, let's call it a flat rate per month. Part D, what will the charge for 100 minutes of service be? How do I find out the charge, C, cost, for 100 minutes? Yeah.
Plug 100 in first.
Plug 100 in for?
X.
Yeah, in this case M, but X is the same thing, right? Yeah.
Yeah, use X and
Yep. It doesn't matter what you use as variables, X, Y, Z, doesn't make a difference. We plug in 100 for the independent variable. When the question says, how much does it cost for 100 minutes? 100 goes in for minutes. That's the only reason I would use the letter that represented the word, so later on you know what went with what. So by using M for minutes, it's very easy to simply interchange 100 for the M there and say C of 100. So you go ahead and plug that in. So 0.05 times 100 plus 25. That will give you the monthly cost if you used 100 minutes that month. Obviously, you multiply what that is. Did I do something wrong? You all heard it right away. What did I do wrong?
Nothing.
I just have a question.
Yeah,
Why
that
do
was,
we have
all three of you put your hand up. That's usually indicating that I screwed up.
Why do we have to add $25? It doesn't say what is the charge for 100 minutes of service a month.
Yeah, that would be the way you interpret it. So that's a really good part. So you have said, it says, what will the charge for 100 minutes of service be? The 100 minutes charge will be here, but this is automatic. So it should say, what is the monthly charge if you spend $100? If you spend 100 minutes.
If it was on a test, what would we?
It would be more clear on a test. This is just a worksheet I made up a while back. Yeah. But depending upon your interpretation, honestly, you give a statement afterward and it's right either way, the way you interpret it. I actually gave a physics test the other day and one of my students was doing a multiple choice and underlined a part of the question that, so one of the answers was 100% right. And then one of the other answer choices, I could have seen what he meant by it possibly being the right answer. And he underlined it on the test, and I was thinking about it afterward. I'm like, I could see that being right, even though the other answer was definitely right, and it was definitely the right answer. So if he came up to argue with me afterward, I didn't tell him, but I was thinking back in my mind, I'm like, if he comes up to argue, if he argues it well, I'll give him the credit for it. So in the same case, you know what I mean? If you can prove your point, that's fine. So again, his statement is it doesn't say what's the monthly charge, right? So the charge for the 100 minutes is actually just simply this right here, plus the 25 for the monthly charge overall. Okay, and then part E says you can afford a $55 phone bill each month. How long can you afford to talk? So what's the deal here now? What are you given is the question first. What do they give you in part E? What variable is given in part E to you? Or just give me the general term for what you're given here.
The C of a certain number.
Yeah, the C of a certain number. So remember this function right here. We're going to take this function and recognize that this is the cost that we could, account for. So take $55 and plug that in for your overall cost right here. Let's plug in a 55 right here for cost and see how many minutes that can afford us. So if we can charge up to $55 each month and our parents don't care or your parents don't care, and then suddenly you want to calculate how many minutes you can afford, again, that's the cost you can accrue. These are the amount of minutes you can limit yourself to. Solve for M. Make sense? Yes? Any questions on this one? Does this last part make sense? The last part I think is the most important here to recognize when you're given the Y value, right? The cost is the Y value. You're solving for the X value or the independent variable.
So on the test, we do have to end up solving. We don't just set it up, right?
You set it up and solve because it says how long can you afford to talk?
Yeah.
Yep. So you solve for N. Subtract 25, divide by 0.05. Okay? Questions on number 1? I see a lot of you already flying through number 2 on your own. Number 2, suppose that you own a car and it's 40 months old. Right away, 40 months. So you can think about that in years if you'd like to. What would that be in years? What's 40 months in years?
3 years, 4 months.
3 years and 1/3 of a year. 3 years and 4 months. 4 out of 12 is 1/3. Suppose that you own a car that's 40 months old from the automobile's dealer's Blue Book. A Blue Book is something that tells you the value of the car. You find that the trading value is now $3,200. From an old Blue Book, you find that its trading value 10 months ago was $4,700. It looks to me like I'm given 2 scenarios. And when I'm given 2 scenarios, I could think back to my linear functions from 3-4. It's like I'm given 2 coordinates here, right? I'm given 2 coordinates for number 2. So let's start part A. Write a function expressing the trade-in value as a function of cars and ages a month. So, the first scenario, 40 months into having a car, its value is $3,200. What do I write from that? What do I write from that? Rich.
Yeah, so it would be like 40 of C is 3,200.
Close. C of 40 is 3,200. Okay, so we're going to write a coordinate like this for now. That's what we're given in the first piece of information. Because again, as Bridge just said, the value as a function of time, I'm going to use V of t. Okay, V of t in this case is going to equal our general function here. So 40, 3,200. What other piece of information do I have? What other piece? What other piece? I've got 1 coordinate. 1 coordinate is not enough to write a function, ever. I need always a second coordinate at least. What do you got, Hannah?
That, so 10 months ago, so 30,
Very good.
and then 4,000.
Okay, that's the key there, what Hannah picked up on. It says 10 months ago. So if it's been 40 months since you bought the car, 10 months ago it was how many months? 30 months since you bought the car. You bought the car on day 0, 40 months went by, 10 months previous is 30 months after the starting time. Okay, 10 months ago, and you're currently 40 months in. So you've got 2 coordinates. How do you want to solve this? And you have 4 options. How do you want to come up with a function? Can I think of 4 options? 3? No, 4, yeah. There are 4 options you could use.
Well, you can do like delta y or delta x.
So you can find the slope right away. From the slope, you can go to slope-intercept. You can go to point slope. Or if you wanted to, you can go to standard. So again, you can find the slope and use slope-intercept, point slope, or standard form. What's the 4th option I showed you the other day? From 3-9. There was another way to solve the first problem. We did it in the notes from 3-9. There's another way to solve these kinds of problems.
And then plug it into the function, the standard function.
And then what do you get? How do you solve that? How do you find the slope and y-intercept by plugging in the points?
You find, you do the 2 equations.
Yeah, system of equation method. So this is the new method that I showed you in 3.9 that I personally think is really easy. So let me show you what I'm saying. I wish I had more room. This is annoying that I don't have the slides in front of me like you guys do. Let me just slide over for now. So let's say the function is v of t, and I know that the function is mt plus b. Okay, mx plus b, mt plus b, t is in place of x right now. So if I plug in these 2 points here, I plug in the 2 values. So I plug in the value itself of 3,200 here, and that occurs 40 months after owning the car. And then I plug in the value of $4,700, and that occurs after I've owned the car for 30 months. So it looks to me like right off the bat, I've got 2 equations. Why is it so easy to use this method? Who picked up on it last time? It's so simple to solve this. Why? What happens when you do, what can you do to solve very quickly? Very quickly, George.
You could do the
Top
matrix.
equation?
Matrix.
You could do the matrix, yes, but it's even easier. I did it in class.
You use the first equation to balance the
Yeah, just subtract the equations. What happens to the b values? When you subtract equations, they cancel. The b values drop off when you subtract equations here. So subtract straight down. You got 40m minus 30m. How many m's? 10 m's. And 10 m's equals a negative number. It's not a coincidence that your slope is negative. Why is the slope negative? We'll talk about that in a moment, but why?
Because the price of the car goes down.
Yeah, the car loses value over time. So it's got to be negative. 3,200 minus 4,700 is negative 1,500. Divide by 10, negative 150. God bless you. Okay? Negative 150 is the starting value, is the slope. How do I find the b value? How do I find the b value? Hannah?
Just plug m up into that first.
Yeah, either one, right? Okay, so take m, plug it in here, or plug it in here. So take negative 150, plug it in for m here, or for m here, to find the actual starting value, to see what the value of the car was when you bought it. And that's going to probably be one of our questions, I think, on this one, I think. Let's see if it does turn out to be one. What do you get for b? What do you get for b? If you plug in negative 150 into the first one, you'll get negative, what is that, 6,000. I take that, add it over, I got 9,200. Verify that for me. What do you get for b? Is that right? 9,200?
Yeah, that's what I got.
So you got, Luke?
Yeah.
You're not just messing with me, right, Luke? 9,200.
Yeah, I need you.
All right. It seems right to me when you plug it into this equation. It makes it add these, right? 1.5 times 4 is 6. 150 times 6 is 6,000. Take negative 6,000, add it over. 6,000 is 3,200. 9,200. So that's our function. That's the m value, and that's the b value. So take this function, please, and rewrite it with these values in it. Take these two values for m and b, and rewrite this original function we started with. That'll be our answer for part A. So let's write this at the bottom here. V of t is equal to negative 150 t plus 9,200. Okay, there's our function right here. Value as a function of time. Part B, you plan to get rid of the car when its trade-in value drops to $1,000. How much longer should you keep the car? This is a tougher question than it looks. You want to trade it in when its value drops to 1,000. George, how do you start?
Well, I was just thinking that if you could take the 32,000 and you get 22,000, and the difference that you can divide by negative 150 to find the months.
Okay, that's one way to do it for sure. George is saying, you know what, let's start with the value of 3,200 that it is right now. Let's see how many months it takes for it to drop to 2,200 from there. That's one way to do it, but there's a much easier way to do it. Much easier way. Go back to the last problem if you need to and look at part E. George, go back to the last problem and look at part E. And then compare part E to part B from this one. Luke, want to help me out? Go ahead.
So you do 9,200 minus 150m and set that equal to 1,000, and then you solve for m.
Yeah, so take what he's saying is this, guys. Look at the function here, please. I'm pointing to it so you can see. Set the value equal to 1,000 and just solve. Again, set the value here equal to 1,000 and solve for t. That will tell you how many months into owning the car you should sell it. From that number, you should probably subtract 48 because you're already 40 because you're 40 months into owning it right now. So set this equal to 1,000. Put 1,000 in here. You get 1,000 equals negative 150t plus 9,200. Subtract 9,200. We get negative 8,200 over here. Negative 8,200 over negative 150. What do you get?
No, it's not.
It's not going to be an integer, yeah. It won't divide evenly. That's why, George, you were going to go by 150 every time. It wouldn't have worked out well for you doing that way because it's not going to turn out to be an exact amount of months. What do you get when you solve for t here?
It's
Yeah?
like 54.66.
All right. 54 and 2/3 of a month, and 2/3 of a month. 54 and 2/3 of a month is the time it takes. How many months in are we though right now to owning this car?
40.
Currently, how many?
40.
We're 40 months into owning this car to start the problem. It says you've owned a car for 40 months. And after 54 and 2/3 of a month, you should sell it. So what's our actual answer for part B?
14.
How much more should we wait?
14 and 2/3.
14 and 2/3. Because currently, you bought the car here. This problem started 40 months in. You're told now you should sell it after 54 months. So 54 months and 2/3 minus the 40 months you're already in means you need to wait another 14 and 2/3 of a month to sell this car. Okay, 14 and 2/3. Oops, I'm on the wrong one. All right. Part C, what does the slope of the function represent in the real world? Why is it negative? We already talked about why it's negative, but what does it actually represent? What would the units be of negative 150? What would the units be for negative 150? For negative 150? Not just dollars.
Decrease of dollars a month.
Dollars per month. It's per unit time. Remember, it's a rate. Think about slope. Pause. Think about slope. Slope is a rate of change. So the units have to be something per time, right? Dollars per month. Gallons per minute. Miles per hour. Those are all rates of change. It's always per unit time. So this case, this slope, it says, you know what the car's value loses how much? $150 every single month. So this is dollars per month. All right, so part C, what does the slope of the function represent? The change in the value of the car each month. Why is it negative? The car is losing value. When do you predict the car will be worthless? George, I want you to answer this one because before you started off and you had trouble with it, now I think you can get it. When is the car going to be worthless? What should we do with that, George?
You said value is 0.
Very good. See this right here? Simply, if you want to know when the car is worthless, change 1,000 to 0. You're setting the value equal to 0. Again, I'm not going to go through the math behind this, guys. I'm just talking about it. Part D would be set the value equal to 0 and solve for t. It says when. When you hear when, think time. After how many months is really what it says for part D. After how many months will it be worthless? According to your model, what was the trade-in value of the car when it was new? Which is really not called the trade-in value. It's really the value you bought it for. What was the value of the car when you bought it? It's obvious. It's sticking out. It's jumping out at you right now. It's literally flashing. You don't see it? Max, what do you got? 9,200. Good. You should have all raised your hand right away. What is this called? The y-intercept, or the starting value. So the value of the car when you bought it is really the y-intercept. It started worth 9,200, and every month it lost $150 until eventually it became, in this case, one of them worthless or $1,000. But this was the value that you started with, your starting value. Okay? So I'm going to go for the review next. What I want you to do is this. Tonight, when you're practicing, take 3 and 4 as practice problems. I would really suggest that you do that because you're going to have a problem on the test that's going to be giving functions with interpretations. Okay, not just giving you 2 points, come up with the function mathematically. Great, you come up with an equation. I want you to actually be able to interpret it. So these are the kind of questions you can expect for one of those like longer ones at the end of the test. You could expect part of this with several parts, or I ask you to interpret the slope, interpret the y-intercept, answer questions such as these.
Are you going to do the thing where we choose certain questions, or are we doing all of them?
It's probably going to be all for this one. Tomorrow's an A day. There's no need to shorten the period. I'm going to give you part of the test with a calculator, part of it without a calculator. So be ready for this kind of stuff. You should be able to solve a 2-system equation by hand with elimination or substitution. You should not need a calculator for it. If that presents itself, obviously. I'm trying to think. You did systems of linear inequalities. That's where that would show up to find the intersection of them. So maybe we'll start with an example with that. Let's start. First of all, let's just quickly jot down what the test is on. So we started this test with section 3.5. And we went all the way to 3.10. 3.5 was a system of equations, right? 3.6 was applying systems of equations. So 3.5 and 3.6 were systems. 3.7 was linear inequalities, and looking for the solution set where we shaded a region. And 3.8, 3.9, 3.10 was linear functions, interpretations of linear functions. So as far as word problems are concerned, let me give you a little preview. Here's what you can expect for word problems. You can expect a problem with a system of equations. That's an application. Again, you could expect a problem with a system of equations. That's an application. You did this on one of your quizzes. Do you remember when you went the problem? You go to the candy store and buy different types of candy and stuff. That was a system. It was on the first quiz of this section or from this test. You could expect a linear function problem that we just went over. Those two for certainty. You can expect both. No calculator portions. You can definitely expect to solve a system of 2 by 2, but the part on the word problems, I'm going to expect you to use a matrix. It's going to be 3 by 3. I'm telling you that now, or more. So you need to be able to use a matrix to solve.
Can we go over that?
Okay? Yeah, I can, but I'm going to do that individually because that just takes forever to go through every step. And most people know that right now. So just come by today at some point, and I'm happy to go over it. Yeah, come right after. That's fine. Okay, but again, try to advocate. I've had a video up on Moodle on how to do that with the matrix for like a week and a half. So you should definitely practice with that. So let's go through an example of systems of linear inequalities because I feel like people really struggled on the test or the quiz that we had. So if I give you two functions and it does not matter what they are, let's say y less than or equal to 2x plus 4 and y greater than negative 1/3 x minus 6. And then I also tell you that x, let's say this is x. Okay, so three inequalities. Inequality 1, inequality 2, and a compound inequality. So you've got some boundaries here. You've got some boundaries. You've got a less than or equal to as opposed to a greater than. What's the difference when it's an equal to symbol underneath it when it doesn't have an equal to symbol? How do we show that on a graph? Yeah. So here, this is a dashed line versus a solid line. Dashed line, solid line. So these boundaries, what are they going to be? Dashed or solid? Dashed. How do I draw boundaries at x equals 5 and x equals 2? What does that look like? What does that look like graphically?
You would put open circles on the ends.
But again, I'm graphing like this, right?
Yeah.
My question is, how do I draw x equal 5 and x equal 2 graphically? Hannah?
Put
Dotted lines. Dotted lines. Okay, so go dotted lines this way, and dotted lines this way. Okay, so that's clearly 2 and that's 5, so let's put increments. You were thinking of the
it was one,
yeah.
it was
Number line.
Yeah.
Yep. So this is our setup we've got here. We know already that our solution set is going to be between 2 and 5. Is that clear? Look at the actual setup, please. Look at the last inequality at the bottom. This tells me that our solution set, its domain is restricted between 2 and 5. 2 and 5. The reason we know that is because these are the endpoints of an inequality, which means it's the end of our answers. Our answers can only range in here. And if you go back to what Annette was even saying before, if you were to graph this on a number line, it would be open circle at 2, shaded, open circle at 5, which means that the answers go between 2 and 5. Look, here's our answer region between 2 and 5. That's why I didn't even need the other second and third quadrants. I might need the fourth quadrant, let's see. Yeah, we're definitely going to need the fourth quadrant, actually. So let's scroll up a little bit so we can add that fourth quadrant in. Let's extend this y-axis a little bit. Make that look nice. Okay, extend the y-axis a little bit there. Now, we have to graph our two inequalities. 2x plus 4. I'm going to go up to 4. If my slope is 2, the simple way to do this, go up 2 over 1, up 2 over 1 consecutively. Okay, go up 2 points over 1. Up 2 points over 1. So this is gonna be an ugly looking line. And that's a solid line there. The next one, y is greater than negative 1/3 x minus 6. I have to go down to minus 6, and I have a slope that's going to decrease now. This is going to be tough for me to draw here, so bear with me. Okay, a slope of negative 1/3. Here's my starting value at negative 6. I go down 1 over 3. Down 1 over 3. Okay, so there's my two inequalities right there. I'm going to extend my red line so my domain continues to extend. And I look at this graph and I ask myself, whoa, what's going on? I've got, ready? Let's point this out real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible regions that could be a solution. But you should know already that it's somewhere between these lines. So it's either this region right here, this little quadrilateral shape, this region up here, or this region down here. It's A, B, or C. That's all it could be. And the reason that I know that it's all it could be is because of this inequality right here. This tells me that my answer has to lie between 2 and 5 on the x-axis. So these red boundaries already show me that it's going to be either inside here, or inside this region if I continue upward. What region do you think it's going to be? George? B is this one or B is this one?
The middle one.
The middle one. Yeah, why is this the answer?
Because one of them, one on the bottom is greater than, so it has to be above it, and yet one on the top line is less than or equal to. So
Has to be.
yeah, it
Has to be below it. Have you picked up on this by now? You can test points, but if you ever set it equal to y or solve for y, just read what it says. This says less than or equal to, right? So I take the function wherever it is and I look below it. Here's the function. Follow this function. That means that everything below this line is in my solution set. Well, this is not in the solution set because of these inequalities right here. But if I take a look at this line and continue it, everything below it is in the solution set. Here, this tells me y is greater than negative 1/3 x minus 6. Well, that's here. That's this inequality. Everything greater than that is everything above that. So everything below this line, everything above this line, and everything inside of these two lines, well, that's this region right here. So our solution set for this problem would turn out to be this region right here. Okay, that entire region right there. So on the test, as far as mathematically understanding this, you need to think about your graphing lines here, right? So you got to really go back to 3-4 and practice your graphing if you're struggling just to graph these lines. When in doubt, though, when you have trouble with graphing lines, the easy way to do it is to find the x and y intercept and then just connect those 2 points, and you get a linear function. Okay, so if you didn't know well, it might be tough here because the x intercept would be all the way back here, right? But this point is 4. The x intercept, we'll just set y equal to 0. You get negative 2. So this is a coordinate negative 2, comma 0. This is 0, comma 4. Put those 2 points there and just connect those with a straight edge. Remember, if you have 2 points on a line, you can graph the line. You don't need to use slope intercept if you really don't want to. Okay, that's what you could expect from 3-7. Okay, is there anything else from 3-7? No, not really. Okay. Sections 3-5 and 3-6, you need to be able to solve by substitution and elimination. I need to see both skills. The reason being, again, I'm not doing this to make it annoying. I know that you can choose one or the other, but one works better than the other in certain circumstances. And you're going to see this progress as you get older in your advanced math courses. There are times when you really want to use elimination. And there are other times, especially in physics, where you have a lot of variables, where you're going to use substitution. So you need to be able to perform both of these skills. So to quickly reiterate, the goal of elimination, let's say this is my function here. Okay, and I want to solve this system right here. What is the goal of elimination?
to get rid of one of the variables.
Yeah, to get rid of one of the variables. Which variable do you think would be easier to get rid of? Why? Because it doesn't have a coefficient for one of them. Whenever you see something without a coefficient somewhere, it's very easy to get rid of it. Okay? How do I get rid of it? George?
Multiply by -3.
Yeah, multiply the second equation by -3. That gives me 9x minus 3y equals -12. Again, multiply by -3. George, why did you do that?
That way the -3y and 3y cancel out.
Yeah, so I can take these two equations now and see that if I add them together straight down, the 3y and the -3y, they'll cancel. So add them straight down, we're going to get 11x. The y's drop off, and we're going to get -4. So x equals -4/11. Please don't let that confuse you if there's a fraction in the answer. Your answers do not need to be integers. Okay, they never need to be integers. They never need to be integers. What do I do once I get the x value always?
You plug it back into the original equation.
Which one?
I guess the second one.
I would agree. How come?
Because y doesn't have a coefficient.
Exactly. See what Bridge said? It makes sense to take this answer and plug it in right here, and then use this equation before you altered it and solve for y. Because y doesn't have a coefficient. It's going to be really messy. You're going to end up with negative. You're going to end up with 12 elevenths plus 4 equals 4. Plus y equals 4. I would multiply everything by 11 to get rid of the 11, and then solve. Okay, again, take the negative 4 11ths, plug it in for x, multiply everything by 11 to get rid of that denominator, and make life easier on you. I saw a hand go up at some point. Did that question get answered? You good? Okay. So your answer, how do you write your answer? As a what? Your answer could be expressed as a coordinate because it's an ordered pair.
It's like an intersection.
It's exactly what it is. It's not like it is an intersection. Very good. It is an intersection. Now, we had several circumstances, didn't we? We had several circumstances for this. You could have an intersection where there is one solution. What are the other options? There's no solution, and then an infinite solutions. So graphically speaking, you should be able to interpret this. If I give you a graph and ask you, this is shown below is the graph of two functions, determine the solution of those functions. Even without the equations, if I give you this graph, and assuming you have coordinates, right, listed like this, or increments, you should be able to tell me what the answer or the solution was to this solution set, or this system of equations. Okay, that in this case would be 3, 2. This is not this example on the right. These are separate examples, please. Okay? These are not the same things. No solution would look like lines that are what? No solution. The lines are? Parallel. And then infinite solutions?
Be like the same line.
It's the same line, actually. The line would lie on top of the other line, therefore intersecting it infinitely many times. Every point on that line is an intersection. But that's rare. You see, yeah, I mean, I'm probably not going to need to show that, but you should understand the 3 interpretations. Okay? Mathematically, though, that's a really easy problem because the functions are the same. They just differ by some multiple. Okay, whenever you see that, functions that would be the same would be like this one. Take everything in this equation and multiply it by 3. And you look at those together, right? Something like this. So these two as a system would be the exact same line. It's the exact same thing. Okay? So you have systems. Now, applying systems. This is in section 3.6. In section 3.6, what was the whole idea? What did you need to always start with? What did you start with that made your problem a lot easier?
The let statement.
Yeah, start with some sort of definition for a variable, please. We call them let statements, but whatever you call them. Start with the definition for each variable. Let x equal the number of, what did we do in class? We did the burgers from Shake Shack, right? And the prices came out to be not really reasonable compared to what they are nowadays. So we did the burgers from Shake Shack, and the final answer was finding the cost of a burger, fries, and a shake each. So B stood for burgers, F stood for fries, S stood for shakes. I traditionally use the first letter. It doesn't matter. X, Y, Z is fine, but you need to make sure that you have the correct letters. Now, once you come up with your equations, what do you have to make sure about the equations? It was a key that some of you forgot on the quiz. Let's say these are my equations, okay? My second equation. And my third equation. Three equations, 3 variables. You should just type it right into my matrix, right? Just type it right in, solve. I'm done. That's it.
You have to have all the variables in the same column.
So when you make a matrix, Luke, what do you think about putting on top of the matrix maybe to help you?
Like the variable.
Yeah, maybe put headings here, please. Some of you did this on the quiz, and those that did a pretty good job aligning them. What I put a number sign for, I just mean the constant at the end. Okay, the constant. So what would you have on the x column?
2, 0, and -2.
So again, look at this. Here's the 2 coefficient for x. There's nothing here for x, hence 0. Here is -2 as a coefficient. That goes here. Okay, Max, the y values, please.
5, 2, and then 0.
Good. Bridge, the y values, the z values, please, even though I wrote y.
-3, 3, and 4.
Okay, yeah, the numbers at the end. What do we got?
12, 14, 28.
Okay, simple enough. Now, if for some reason your constants are on the left-hand side, which we did an example like that, you got to remember to move your constants over to the right-hand side before writing the numbers down. Okay, they have to be on the right-hand side, or else the sign would be the opposite. If this 28 were over here, how would it appear? It would appear as a -28. And then when you add the 28 over, it becomes positive. So it's got to be on the right-hand side. If you wrote down negative 28, you're not going to get the correct answer. And that, yeah, so this goes right into your matrix in your calculator, and it spits out an answer. And the answer always has ones along the pivots. That was the key. Your answer will always look like this, provided you typed it in right. If you didn't type it in right, your answer it's not going to show an answer at all. It'll show a matrix that doesn't work. Here's what your answer will look like. Okay, and then your answer here will show up for x, whatever x is, whatever y is, and whatever z is there. And how do I know that again? Because remember, this is really a number, right? So say this is a number like 7. This tells me 1x, no y's, no z's is 7. So just x is 7. No x's, no z's, and this is y. This says 1y equals 8. So y equals 8. So this is what x is, this is what y is, and this is what z is as a number. Okay, but again, these are numbers here. Okay, these are going to all show up as numbers when you enter them on a matrix on the calculator. So the parts that you can use a matrix for, obviously, will be the calculator part of the test. The parts that I'm not going to have use a matrix for, like a 2-variable 2 system, you can't use the matrix for it on there. Okay, but you can always check these problems by taking your answer at the end and plugging them back into the original equation you started with. You should know from the recent stuff, interpretations. So if I asked you for this function to figure out, well, what is, say this is f of x, and I asked you, tell me what the value of f of 2 is. Mathematically, I know that this means plug 2 in for x. So if it's on a graph, I simply go over 2 for x and go up 1 or go up to here, and I'll see that my coordinate turns out to be 2 for the y value. Okay, practice please, a little bit more with 3-9 and stuff. Practice the homework tonight for 3-9. If you have a free today and you want to come by during school, come by. If you want to come by after school, come right after though. I got to go to physical therapy. My shoulder's still messed up, and I have physical therapy at 4 o'clock downtown. So I need to leave by like 3:30 today. So I could give you a half hour. Okay, just come by. Yeah, I'm always here.